Okay, this is the program, and yesterday you people learned how to traverse a given graph by using the depth first search or depth first traversal, and breadth first search or breadth first traversal. So it's not like always you can have only one traversal for DFS. So you can have multiple traversals for DFS. Multiple traversals are possible. So the algorithm is very simple. What you have to do is you have to consider the given node as the starting node. So if the question says considering this as the starting node, traverse the graph using the DFS or BFS, you have to start using that node itself. In case if the question doesn't mention the starting node, you are free to choose your own starting node. Okay, so usually if the nodes are numbered from 0 1, so if the number is starting from 0, usually we go for starting the first node, the node with the lowest number as the starting node. So in case the question explicitly specifies the starting node, you got to traverse using that itself as the starting node. Now when you are traversing it using the DFS, what we do, first we take the starting node and we mark it as visited. Okay, and then we go for finding the adjacent nodes to that. Okay, all the adjacent nodes to the node which you have visited right now will be added or pushed onto the stack. And yesterday you people understood DFS makes use of the stack, whereas the BFS makes use of the queue. We find the adjacent nodes to all the adjacent nodes to the node which I have visited right now, and we push them onto the stack. And again, when I'm pushing them onto the stack, so I prefer pushing the highest number first and next the lowest number. Say for example, adjacent nodes to 0, say assume 0 is the starting node, and I have 1 2 3 as the adjacent nodes for 0. Now what I'll do, I'll prefer pushing 3 first, and then 2, and then 1. Okay, so this is what I prefer. So there is no hard rule saying that you should always push the highest number onto the stack and next the lowest number. So you can go for pushing the adjacent nodes to the node which is visited right now in any order, but this is what I prefer, and I insist you people also to follow the same. Okay, we push them, and then we go for visiting again the node which is there on top of the stack. So when I visit that, again I go for pushing the nodes which are adjacent to 1 if it is not already in the stack and if it is not yet visited. So I keep repeating this process until the stack becomes empty. Once the stack becomes empty, so the visited list gives you the DFS traversal. Okay, and similarly when you are doing it for the breadth first search. Okay, so first visit the node which is given as the starting node, and then go for visiting all its adjacent nodes. Okay, so that is what we say. For example, 0 is the starting node, 1 2 3 are adjacent to 0. Now after 0 I go for visiting 1, and then I visit 2, and then I visit 3. Then I go for recursively taking the node 1 and visit all its adjacent nodes if it is not yet visited. Okay, so that is the reason it is called as breadth first search. So we are searching widthwise in BFS, and when I take DFS, we are searching or traversing the given graph in the height wise or the depth wise. Okay, now we'll go for this lab program. Yesterday it was not possible for me to complete this because of time restrictions, so we'll complete it soon, and we'll take one more example after this. And this is a very small program, and it will not take much time. So I have one array with the name visited, integer array with the name visited, because once a node is visited, I'll be adding it to the visited array. Okay, so visited of max, and all these things are made as global variables because I want to access all of them in all the functions. Okay, so I need to access this visited in the main also, and I want to access this any other function which I'm writing. And then to read the adjacency matrix, I've taken an array with the name A, a 2D array with the name A. Okay, and then n is the variable which is taken in order to read the total number of vertices required. And after that, so we have two prototypes, because we have two user defined functions in our program, one with the name read adjacency matrix, another with the name DFS, depth first search. And the question says you can go for traversing the graph either using the DFS or using the BFS. So we prefer, I'm using here the DFS, because that is easy, because stacks, when you call a recursive procedure, stack is inbuilt and you don't have to explicitly create a stack and perform the push operation. Okay, so whenever you are doing the recursive function, the stack will come by default. So if I use BFS, then I should go for explicitly implementing the queues, and the program will become complicated. Okay, so DFS, because the question says DFS or BFS, you can go in for using this. And later on, okay, I'll be showing you the program for doing the BFS also. Okay, so there you understand, in case if the examiner, so they should not ask, since the question says DFS or BFS, either you're free to choose either of these two traversal techniques. So on top of that, if the examiner asks, can you do it by using the BFS also, you should be knowing. Okay, for that we will discuss a different program. Okay, so as of now we'll try to do with the DFS. Now in start, and then I have read adjacency matrix, because I have taken a variable with the name start, and before I start, I have to read the adjacency matrix. And how to write the adjacency matrix? So before writing adjacency matrix, you have to take a piece of paper and you have to write a graph. So try writing your own graph. Okay, so later I'll show you an example, and I'll take a matrix, adjacency matrix, and then using that adjacency matrix I'll try to write the graph. Okay, read the adjacency matrix. So when this function is called, we come here. So this is pure reading the matrix. Okay, enter the number of vertices. I'm reading the number of vertices to n. See, n was declared as a global variable. Now I can even access it inside the function read adjacency matrix, and then enter the elements of the adjacency matrix. So you know how to read a matrix, so you got to make use of two for loops. That is the reason I have taken two local variables I and j. Now, and I, the outer loop again, I'm going to run it till I is less than or equal to n, and the inner loop is also I'm going to run till j is less than or equal to n. Okay, and then I read it to the matrix, which is again a global variable which is declared before the main. So this function is basically reading the matrix, and you're already familiar with how to read a matrix, two-dimensional matrix. Now after reading the matrix, so it is asking us to enter the starting vertex. Okay, because you got to explicitly say from where you have to start traversing the graph. Okay, and I'm reading it to the start. Okay, so another variable we have taken here with the name start, which was declared inside the main. Now here I'm reading the starting vertex, I'm storing it in the start. And next thing is directly calling a DFS function by passing the start. So DFS prototype, you can observe here what DFS is doing. So it is taking an integer argument, and what is that integer argument we are passing? The starting node. So let us go to DFS, and this DFS, what we are doing now, we are writing it as a recursive function. I'll go to DFS. So this is the DFS function. The whole entire program is only this much. It's only this much. One second. So now, DFS function. So starting node, we have passed it to gets. This is the formal parameter v, and then int w. Okay. So this is another local variable which is declared over here. And now visited of v, I am making it as 1. So v is nothing but right now the starting node which we are passing from the main function. So that I am making it as 1. Okay. So whenever a node is visited, I'll mark it as 1. So this 1 indicates the node node is already visited, and if it is a 0, it indicates that the node is not yet visited. Okay. Next, for w is equal to 1, then w less than or equal to n, w plus plus. So I'm running a for loop here from 1 to w is equal to 1 to w less than or equal to n. Now every time, so on every iteration of this for loop, what I'm checking is, I'm checking whether the node is visited or not. Okay. Now how do you check whether the node is visited or not? If visited of w equal to 0, what does it mean? It is not yet visited, and we are and there has to be a path from what, the vertex v to the vertex w. Okay, so v is already visited, and there has to be a path from vertex v to w. So if it is 1, if there exists a path, then I go for printing it. So I'm just printing it, the value w and then an arrow. Okay, and then so I recursively make a call to DFS. In case if the node is already visited, then what I do, I don't do this. Okay, I don't do this. And in case if there is no path, I skip this. Okay, I skip this and I say return. So I was mentioning backtrack right earlier, so that is what we do here. Okay, now whenever, so both the conditions should be true, the node should not be visited and there has to be a path. Say for example 0 is the starting node and 1 is its adjacent node. So 0 to 1, if there exists a path, then I go for printing 1. Okay, I print 1 and then I call DFS again by passing 1. Okay, I call DFS by passing 1, so it comes here and again 1 will be marked as visited. Okay, and then again I run a for loop. I take every node and I keep checking these two conditions. Okay, and wherever these two conditions are satisfied, I print, okay, the node, and again I call DFS. In case if these two conditions are not satisfied, I keep backtracking. Okay, so if, for example, sometimes you reach a dead end node, and then what we do, we backtrack to the parent node until it's possible for us to reach the other unvisited node. Okay, that is what happens. So I hope people understood with this program. And
Yes, sir.
where is the stack here? This recursive function call itself will create a stack and add whatever correct, right, you're using. Okay, so you don't have to explicitly create this stack here. Okay, so if you're using BFS, then you have to explicitly create the queue, because recursive function call works with the stack. Without the stack, you cannot have the recursive function working. Okay, now let me go for executing this, and before executing, let us take an example. What example I'll consider now is, let us go for taking this example. Okay, this is the adjacency matrix what we are taking now. So for this adjacency matrix, so first let us write the graph. Okay, how many vertices are there? This is the input which will be giving this adjacency matrix. But for this, it's always better to write. Okay, so first you have to write a graph, and then from the graph you should be going for writing the adjacency matrix. So let me write the graph. So I'll take a blank slide. Let me do one thing. So let me print the screen and paste it here. I need only that adjacency matrix. Let me take only this much. Yeah. Now for this adjacency matrix, if I write a graph, yeah. See how many nodes are there? This is 0, 1, 2, 3, 4, 5 nodes. Okay, and it's a 5 by 5 matrix. Okay, so let me consider call the first node as the 1, second node as the 2, 3, 4, 5. Okay, so I'll write 1. Okay, now 1 to 1 there is no path, and this is 1, 2. So all of you write the graph for this. This is 2, 3, 4, 5, and similarly this is here 1, 2, 3, 4, and 5. Say 1 to 1 there is no path, and 1 to 2 is there a path? Yes, 2, and then 1 to 3 there is a path. That means 2 and 3 are the adjacent nodes to 1, and then 1 to 4 is not there, and 1 to 5 is also not there. Next take 2 to 1. The 1 is already there. The path is already existing. OP people are following?
Yes, sir.
And then 2 to 2, no, and 2 to 3 is also not there. 2 to 4, one path is there. 2 from 2, 4. 4 is the adjacent nodes to adjacent node to 2. And then 3 to 1, it's already there. And 3 to 4, it is there. 3 to 4. So from 3 to 4 you should have a path. So because 3 to 4 it is marked as 1, and 3 to 5 is, so 5 is also an adjacent node to 3. And then 4 to 2, it's already there. And then what is it, 4 to 3 is also there, and 4 to 5 have added. Next from 5 to 3, 5 to 3 is already there, and then 5 to 4 done. Okay, so this is the graph. So for this graph, so this is the adjacency matrix. Hope you understood?
Yes, sir.
Okay, now considering 1 as the starting node, okay, we'll try to traverse this graph using DFS. So 1 is the starting node. Let me write visited here. This is visited, and then the stack, and then the stack. Now since 1 is, I'm saying it as a, consider it as a starting node, you got to visit it. So 1 is visited, and then I'm going to fill my stack by pushing the adjacent nodes of 1. So the adjacent nodes of 1 are 2 and 3. Now as I already mentioned, I prefer pushing first the highest number, that is 3. So 3 I'm pushing it onto the stack, and next I go for pushing 2. Correct, right? So this is the top of the stack right now. Okay, next. So next node to visit is 2. See here, I'm visiting 2, and 2 should be popped out. When I visit 2, it should be popped out from the stack. It is popped out. Next, adjacent nodes to 2. See, the adjacent node to 2 is 1 and 4, but 1 is already visited. Now the next adjacent node to 2 is 4. So 4 should be pushed onto the stack. So 4 is pushed onto the stack, and we have top pointing to this. And the next node to visit is 4. See, we are covering depth. So this is visited. Let me say it as V, visited. This is also visited. And now 4 is also visited. And 4 gets added to the visited list. Okay, now I'll erase, I have to pop this 4 from the stack. Now again, the node which is visited right now is 4. When I go for looking into the adjacent nodes of 4, it is 2, 3 and 5. But 2 is already visited. Now I should be going for pushing. So 3 is already there in the stack. So I should be going for pushing this 5. Okay. So 5 is pushed onto the stack. Okay. And the next node to visit is 5. And the next node to visit is 5. And this top was here. Now 5 is also visited. Now 5 should be popped out from the stack. Okay. And now when I go for looking for the adjacent nodes to 5, it is 4 and 3. 4 is already visited. Now 3 is already there in the stack. Now I just pop this. Okay. I have only 3, but 3 is already there. I just pop this and add it to the visited list. Visited list. So this is the DFS. See how we are going: 1, 2, 4, 5 and 3. So how we visited depth wise. Okay, and this is also visited. Okay, people understood?
Yes, sir.
Okay. Now when I take 1 as the starting node, so this is what the sequence the program should produce for me. Okay. Now we'll go to the program. Let me, yeah. So one of you just make a note of this sequence: 1, 2, 4, 5, 3. 1, 2, 4, 5, 3. So I'm writing 1, 2, 4, 5, 3. I'll discard this now. Okay, I'll get back to my program. I'll maximize it. Now control F9. Yeah, I'm running it, but I need that matrix. Okay, just a minute. Let me copy that matrix, because I need to feed the same matrix. So the matrix is 0, 1, 1, 0, 0. I want you people also to copy this: 1, 0, 0, 1, 0, 1, 0, 0, 1, 1, and 0, 1, 1, 0, 1, and then 0, 0, 1, 1, 0. Okay, people copied it?
Yes, sir.
Okay. hope all of you can see the screen, output screen.
Yes, sir.
Okay, so number of vertices, 5 vertices. Now enter the adjacency matrix 0, 1, 1, 0, 0. And next row is 1, 0, 0. See, before writing the adjacency matrix, you should have a graph with you. So write one graph, and for that you write the adjacency matrix and go for feeding the same. 1, 0, and then 1, 0, 0, 1, 1, then 0, 1, 1, 0, 1, and then last row 0, 0, 1, 1, 0. Is this clear? So we have
Yes, sir.
Fed the adjacency matrix to the program. Now it is asking me to enter the starting vertex from where you have to start traversing the tree. Now what I'll do now, so since I solved it for the starting node as 1, I'll give 1. Okay. Now Alt F5, see the sequence now. Now from the starting node, it is giving 1, 2, 4, okay, 3, 5. Now that is also that is also possible. So because you can have multiple sequences, okay. So 1, 2, after 4. So when I solved it, I visited 5, but what this is visiting is 3 and then 5. Okay, so this is also. Let me go back and show you for this sequence. This sequence is also possible. Now here, so I think I have to write the graph again. One, from 1 there is a path to 1 to 2, and then 1 to 3, and then from 2 to 1 it's already there, and then 2 to 4, 2 to 4, and then 3 to 1 it's already there, 3 to 4, this is the 1, and then 3 to 5, and then 4 to 2 it's already there, 4 to 3 is also there, and then 4 to 5, 4 to 5, and next 5 to 1 to 3, 5 to 3 is there, and 5 to 4 is there. This is the graph. Now starting from 1, okay, see I can come to 1 and then come to 2 and then come to 3, 4, and then go to 3, and then I can also come to 5. This is also a depth first search, something like this, because adjacent nodes to 4 are 3 and 5. Now what I'm doing, after visiting 4, I can either go for visiting 3 or 5. Now what I'm visiting is 5, and then I'm visiting 3. Let me start. Visited, and then stack. Now here, so 1 I'll add it to the visited list. Now 2, 3, sorry, 2 and 3 are the adjacent nodes. I'll add 3, and then I'll add 2. Next I visit 2. So 2 is popped from the stack, and adjacent nodes to 2 are 4 and 1. So I add 4. 1 is already there, 4 is pushed onto the stack, and the next node to visit is 4. So 4 is visited, this is also popped, and next I go for looking for the adjacent nodes of 4. So adjacent nodes of 4 are 3 and 5. Okay. Okay, let me push 3 again. Okay, so if I'm pushing 3 again, so 5 and 3, I push it. So the next node to visit will be 3. So since 3 was already there, I was skipping this earlier. Now I'm pushing this 3 again. 3. So you just go for pushing it again. Okay, 3 is inserted. Okay, and then this is popped, and the adjacent node to 3 is 5. Again go for 3 it is 1 and 5. Okay, I'll push 5 and then I'll push 1. Now I'll just go for visiting this one. Since already 1 is visited, I just pop this and I don't add it to the visited list. And next I go for visiting 5. So 1 adjacent nodes 2 and 3 are already visited. I don't add them into the stack. Now I just go for popping 5, and I just find the adjacent node to 5. It is 4 and 3. So they're already visited, so I don't go for adding anything onto the stack now. Now I just visit 5. I just visit 5, and then this is popped. Okay, and then again 5 is there. Since 5 is already visited, we simply go for popping out this, and again 3 is there. So 3 is already visited, and I just go for popping this out. Okay, now this is the sequence: 1 2 4 3 5. It's okay, 1 2 4 3 and 5. So this is also a DFS. So our 1 2 4 5 3, that is also the DFS. OP people understood?
Yes.
But what the program is doing, every time when it is finding the adjacent node, say adjacent node for 3 and 5. So 3 was already there in the stack, but again it is going for pushing it onto the stack, since we are using the recursive technique. OP people understood?
Yes, sir.
Okay, so now what you do is, when you are doing DFS, so even though the element is on the stack, and when you are finding it as the adjacent node for some other node, so keep pushing it. So if it is already visited, what we do, instead of adding it to the visited list, we go for discarding it. We just pop it and delete it. Understood now? So 1 2 4 3 5 or 1 2 4 5 3. So both are what the DFS traversal. Okay, now so for the same thing, if I write the BFS, so just by looking into this, you can go for writing. So 1 is the starting node. Say I visit 1. So I think 1 second. Yeah, 1 is the starting node, and then 2. Sorry. So 1 is the starting 1, and next I have to visit its adjacent nodes. So 2 I'll visit. Next I visit 3. Next I go for taking 2 and its adjacent nodes. 2 adjacent node is 1 and 4. 1 is already visited. Next thing to visit is 4. Next I take 3 and its adjacent node I'll try to find. 4 and 5. 4 is already visited. Next thing is 5. Okay, next I take 4. So 3 and 5. So 3 is also visited, 5 is also visited extra. Next I take 5. Now 5 adjacent node are 3 and 4. So again 3 and 4 are already visited. This is the BFS. Hope it is clear?
Yes, sir.
Okay, now and I think here yeah, sorry. So this sequence was written by taking the starting vertex as 3. Okay, so you can also check by considering 3 as the starting vertex, and you have to get this sequence. So we'll do that. So 1 second please. Okay, so if I take the starting node as now 3, so I have to get for the same adjacency matrix. So for starting node 3, I have to get this as the sequence. We'll just try to do that. So from the node 3, we'll write it. Try to write it from the node 3. Let me erase all these things. Am I audible?
Yes, sir.
Okay. So from this, okay, stack. So from the node 3 I'll start. I'll consider this as the starting node. So now adjacent node to 3 are 1, 4 and 5. Okay, 1, 4 and 5. These are the adjacent nodes. Now I'll push them onto the stack. So 5, 4, 1. Okay, and our next node to visit is 1. Okay, this is popped. Next I go for finding the adjacent nodes to 1. Adjacent node to 1 are 1 and 2 and 3. Okay, so I'll go for pushing them onto the stack. Let me push 3 also. 3 and 2. Okay, and now the top of the stack is this, and 2 gets visited. 2 is visited and this is popped. Okay, and when I go for looking into the adjacent nodes of 2, it is 4 and 1. Okay, so let me push 4 and 1. Okay, next node to visit is 1. Since 1 is already visited, I just go for popping it. And next node to visit is 4. Okay, and next I go for finding for 1. Okay, so I think this is 1 second, I missed 1. Okay, I visit since 1 is already visited. Okay, I pop it out, and 4 is the node which is not yet visited. I'm visiting 4. Now this is removed, and I go for finding the adjacent node for 4. Adjacent node for 4 are 3, 2, 3 and 5. Okay, 5, 3, 2. Okay, next node to visit is 2. Since already 2 is visited, I pop it. And next node to visit is 3. Since 3 is already visited, I pop it. And next node to visit is 5. 5 is not yet visited. I'll add 5. I'll visit 5. Okay, and I go for looking into the adjacent nodes of 5. Adjacent nodes of 5 are 3 and 4. So push it onto the stack. 4 and 3. Now 3 is already visited. Okay, so pop it. Next 4 is already visited. If it is already visited, you have to just pop it. And then Next in the top is top of the stack is 3. 3 is also visited, pop it. And 5 is also 4 is also visited, pop it. And 5 is also visited, pop it. Now this is the sequence 1 3. So 3 1 2 4 5. Okay, so this is what we need to get when I give the 3 as the starting node. Let me keep this, let me write this sequence. So 3 1 2 4 5. Okay, number of vertices is 5, and again I need to enter the matrix. One 0 0 1 1 0 1 1 0 1 0 0 1 1 0. So starting node 3 I take. Okay, so you can see now it is, so 3, from 3 the next node to visit is 3 1 2 4 and 5. Okay, so this is what the traversal when you get when you are visiting the node 3. Okay, starting from the node 3. Hope it is clear.
Yes, sir.
Okay, so now similarly you can go for trying from the different node, other nodes also. Now what we will do is I'll give one more example for you people to solve. Just try to do that. Okay, this has stopped working. Okay, so am I audible?
Yes, sir.
Yeah, I am giving you one more graph, and try to write the DFS and BFS for this. Okay, this is 3, this is 6, and this is 4, and 1 2 3 4 5 6. Okay, correct. Two to 1, so digraph it is, and then 1 to 2, and then 1 to 3, and then 3 to 2, and then 3 to 6, write down the direction properly. 2 to 6, and then 6 to 4, 5 to 4, and then 6 to 5. I think I've written all. Okay, 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 okay. Yeah, and for this you just try to write it. Okay, copied this.
Yes, sir.
You copy this and try to write the both DFS as well as BFS. And earlier what we were doing was, if it's already there in the stack, we were not pushing, but go for pushing it. Okay, and if it is already visited, just pop it. Okay, just pop it. It'll solve, no?
So starting node.
Take 1 as the starting node. So if starting node is not mentioned, you take the minimum number as the starting node. So take 1 as the starting node and try to solve it. Okay, I'll just show you. What is the time now? Can I take it for 5 more minutes?
Yes.
Okay. So we will quickly do it for DFS, and BFS you can do by yourself. So this is visited, and this is the stack. So 1, I'll visit it. Next, adjacent nodes for 1 are, so just for directed edge it is, you have to follow the edge. This is the 1 and 3, 2 and 3. So I go for pushing 3 first, and next 2. Okay, and next node to visit is 2. Okay, 2 is visited. I pop this. Now I'll go for adding the adjacent nodes of 2 to the stack. Adjacent node of 2 are 1, 5 and 6. So I'll first push 6, and then 5, and then 1. Okay, next node to visit is 1. Since 1 is already visited, I pop this. Okay, so 1 was already visited, I just pop this. Next node to visit is 5. I visit 5. Now 5 is also popped. So and now I go for finding the adjacent nodes of 5. Adjacent node of 5 is 4. So 4 gets pushed. So only adjacent node is 4. So our next node to visit is 4. So this is popped, and add the adjacent nodes of 4 to the stack. Adjacent node of 4 is, there is no adjacent node of 4. Okay, so 4 is added. So that's all. See, 4 we don't have any adjacent node. Next thing to visit is, say after 4, since there are no, we backtrack, we go back to 5. Okay, and then we go back to 5, and then visit yeah, we backtrack twice here. We go back to 5, and then we go back to 2 also, and then we visit 6. Okay, so 6 is, and adjacent nodes of 6 are 4 and 5. I'll add 5 and then 4, and next node to visit is 4 again. Since 4 is already visited, I pop it, and next node to visit is 5. 5 is already visited, I pop it, and next node to visit is 3. So 3 is visited, and I just find out the adjacent nodes of 3, that is 2 and 6. 6 and 2 are pushed onto the stack. Now I just try to visit 2, since 2 is already visited, I just pop it. Next I try to visit 6. 6 is already visited, I just try to pop it. Okay, now this is what the DFS. Okay, people understood?
Yes, sir.
Okay, so we'll stop here. Okay, and this program I'll upload it to the Google site now. You can download, and whoever have lab today afternoon, so if you finish till 10, you can go for executing this. And I need to trace this program still step by step execution, that I'll be doing in the next class. Let me download the attendance list. So attendance I don't mark now physically because I have some other work. I'll just download it. Okay, it's downloaded.